All right, class, it's time for our review of trig. So the next few chapters, we're going to talk about trigonometric ideas. So an angle, we're going to start with angles. Obviously, we're going to be dealing a lot with them. So let's see what an angle is. Well, simply, an angle is formed by two rays with the same starting point. What does that mean? Well, a ray, remember, is not full on a line, is just half a line, right? So it starts with one point, which by the way is called the vertex of the angle, right? And then we have two rays, right? A line stretches both ways, a ray stretches only in one way. Okay, so that's all it takes. Now, obviously, if I were to orient this angle a different way, it's really the same angle as long as the opening inside is the same, right? So it's the same angle. We can turn it this way, that way. It really doesn't matter. It's the same angle, right? As long as the opening inside is the same. Now, we usually use Greek letters to label angles. Now, of course, the most famous one, and you've heard it before, is theta. I don't really know how to... I guess that's how you spell theta. Some angles are called alpha. So we're using Greek letters, or beta, gamma. I guess, I don't know how we would say this. I mean, I know how to say it. I just know how you would spell the Greek letters. But alpha, beta, gamma, that's your A, B, C in Greek. But theta is really the most famous one of all the angles. So many times when we're going to label angles, we're just going to talk about thetas. Okay. Now, just as I said, since the angles stay the same as long as the opening is the same, what we would like to do is start computing or doing some computation using angles. So we're going to be orienting them, turning them around so we can fit them on an XY plane. Then computation will become much more streamlined. So I'm going to take the angle above and I'm going to orient it so that one of the rays is on the positive x-axis, the vertex is in the origin, and as I said, the opening is the same, okay? So let's call this angle theta. Now, so also important, it's going to be how we measure this. So again, I want one of the rays to be on the positive x-axis. I'm going to call this the initial side of the angle. And the other ray will be called the terminal side. And now I know that I am measuring my angles from the initial side to the terminal side, okay? So I'm measuring it in this way. So the initial side, so if we can place an angle such that the vertex of it, where the two rays meet, right, is in the origin of the XY plane, obviously. The initial side, and that's it, and the initial side is on the positive x-axis. So from the vertex, right, we're going towards the positive x-axis. We call this angle in standard position. Well, we say the angle is in standard position. All right. So there you have it. There's an angle in standard position right there. Okay. Now, to be sure, we can have the same angle. I'm going to need a different color. This is its initial side. This is its terminal side, but we are measuring it this way. Okay, now that's a different angle. Here, let me call it a different name, alpha. Because we are going counter, or clockwise I should say, we call this a negative angle. Okay, so an angle measured counter clockwise is a positive angle, has a positive measure. We'll talk about measure in a minute. And an angle measured clockwise is a negative angle. All right. So there you have it. Now, of course, we can measure angles multiple ways. In fact, these are not the only two angles that have this initial side and this terminal side. By the way, initial side, they all have the same initial side. Why? Because we want these angles to be in standard position. So the initial side to be on the positive x-axis, that makes an angle in standard position. So several angles in standard position will also have the same terminal side. These two right here already, right? One's a positive measured this way, one's a negative, but that's not all. You can start measuring this angle here, well, again, on the initial side, and measure round and round and round and round, and then end it right there, okay? So you don't have to stop right away. You can go round and round and round and round around the XY plane, around the origin several times before you decide to stop on that terminal side. And same thing, we can start with a negative angle, right? You have to start on the initial side, measure, 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 measure until you get dizzy, stop on this terminal side, okay? So we'll talk about these angles in a bit. We call them coterminal angles. So I talked about measure. How do we measure angles? Well, we can measure angles two different ways. One of them is the degree measure. So if you, let's say, start on this initial side and you measure here counterclockwise, so positive, full on one rotation basically, we call this 360 degrees, and we call this a full angle. So a full angle has a 360 degree measure. Its terminal side is the same as its initial side. So we go in a positive direction, yes. Full 360 degree rotation, right? One rotation. Now if I start again, and I could do an XY plane around it, but we're just going to simplify things. So if I start on the initial side and I only go halfway, well, clearly that's 180 degrees only, right? So we call this a straight angle. Just halfway. And sure enough, you know what I'm getting at. What if I stop a quarter way through? I'm going to put its symbol here. That's 90 degrees only, right? So a quarter of 360. And we call this a right angle. So the two sides, right, the two rays are perpendicular to each other. They form a 90-degree angle in between them. Now, why is this 360? Where did this number come from? It's simply a number that has a lot of divisors. It's because you can cut it, you can divide it by 2, by 3, by 4, by 5, by 6, by 8, by 10, 12. There's so many factors. So you cut it halfway, it's a nice number. You cut it a quarter of the way, it's a nice number. So it doesn't give us decimals, right? That's really why 360 was chosen for that measure. Okay. All right, so we have all these angles. What was I going to say? Now, of course, you also know, just to put it, if an angle has less than 90 degrees, right, then we call this an acute angle. Any angle that's less than 90 degrees is an acute angle. And an angle that measures between 90 and 180, right? So we'll talk about quadrants in a minute. So an angle between 90 and 180 degrees is called an obtuse angle. Okay, well, there you go. So again, these are well-known facts, I hope. Just wanted to give you a little bit of a review on this. Okay, so let's see, what else we want to talk about? We want to talk about coterminal angles. I mentioned that as well before. Coterminal angles. These are angles in standard position in other words, what? They already have the initial side on the positive x-axis. So they have the same initial side. That also have the same terminal side. Okay, so let's see. I'm going to give you an angle of 40 degrees. Can you find me a coterminal angle to it? So I'm going to draw it for you. 40 degrees, definitely less than 90, yes, so 40 degrees is about here. Okay, so can you give me another coterminal angle to it? Sure enough, we can do what? We can go clockwise. The whole thing is 360, so if this little chunk is 40, we're going to be left with 320, right? So 360. But it's a negative angle, right? So we're going in a negative side. What else could be a coterminal angle to 40? I could start here, go positive, yes, once around and one more. So 3 full 60 plus 40, that's 400 degrees for that one, right? Or, looking for a different color, I could go where? On the positive side, negative direction, so clockwise, 1 full 360, and then another 320, so I'm going to add up to negative 680. Ooh, this one's not so visible. I have to use a different color. But anyways, here, I'll write it back. Negative 680 degrees. So, really, to end on coterminal angles, we start with our angle, and what I've done is, look, 360 plus one more full rotation, 40 plus another full rotation of 360, right? And that gets me to my 400. What else could I do? I could start at my 40 and add 2 of these 360. So go 2 full rotations around, right? So that's what, 720 plus 40, that's 760. So basically, to go from one angle to another one that's coterminal to it, what do? You just keep adding 360s, right? Or what else could I do? If I go in a negative direction, I can minus 360. So as you see, 40 minus 360 is the negative 320 degree angle that we got, yes? What if I go another 360? So I minus 2 360s, go 2 full rotations around, okay? So that's negative 720 plus 40, that's negative 680. So in other words, to go from an angle to any coterminal angles, what do I simply have to do? Add or subtract 360s to it. So theta plus 360n. That's what I'm going to write. Now, where n is what? Any integer. Okay, so again, it could be 0, right? Then you just have your theta. It could be 1, so you add 1 360, or 2 3/60, or it could be a negative integer, right? Like -1, -1 3/60, -2 3/60. So that's what gets you any coterminal angle. So there's infinitely many of them, of course, because there are infinitely many integers. Now, we have names. Also, it's important for us to know what quadrant an angle terminates in. So I'm going to squeeze this down here. Quadrants. So depends on what quadrant an angle terminates in. We say this angle is in this quadrant. So if the terminal side is in quadrant 1, we say this angle is in quadrant 1. Okay, if the terminal side of the angle, let's say, whatever direction we might be going, it doesn't matter. Let's say I'm going in a negative direction and I end up in the 3rd quadrant, yes? So that's also why it's important that we put these arrows so we know in which direction we're going. So this is a quadrant 3 angle, right? That's a quadrant 1 angle, right? So we say an angle is in this quadrant if its terminal side is in this quadrant. Let's say is in quadrant 1 if its terminal side is in quadrant 1. Okay, so left that there. What I want to do is go over and practice all this. So I want you to draw these angles in standard position and tell what quadrant they're in. So let's start with, I'm going to start with -150. So all I simply have to do is draw this angle. So you have to do this nicely, properly. Draw me the initial side. And because I'm going in a negative direction, I have to start this way. Remember, going a quarter of the way, that's 90. All the way here is 180. So 150 is just shy of 180 degrees, right? But we're going in a negative direction. There's your -150, right? Where does it terminate? It's in quadrant 3. So we use Roman numerals for our quadrants, right? This right here would be 1, 2, 3, and 4. So we use Roman numerals for our quadrants. This one ends in quadrant 3. What about 480? Okay, so starting on the positive x-axis, it's a positive angle, so I'm going in a positive direction. There's 360, and I have to keep on going. 360 plus 90 is 450, and I have to keep on going 30 degrees more. This angle terminates in quadrant 2, so it's a quadrant 2 angle. Okay, so going round and round nicely. Okay, 270. Where's this one going to be? Okay, so I start on the positive x-axis, right? Go, there's 90, there's 180. 180 plus 90, whoops, that's 270. Okay, so I end up on the negative y-axis. What quadrant is that? Well, it's not quadrant 3 and it's not quadrant 4. What am I going to say for a quadrant? Oh, well, it's actually neither, and I'll tell you what they're called in a minute. So -600, let's just do one more. And again, I'm going from the positive x-axis in a negative direction, 360. 360 plus 180, I can't do it, 360, 460, 540, so I have to keep on going, 540, 60 more. Now, by the way, you have calculators. I'm going to end up here in, again, quadrant 2, right? Going in a negative direction. Okay, so what if I don't end up in a quadrant, but I end up with on one of the axes? We call these quadrantal angles. And quadrantal angles end on an axis. And which ones are quadrantal angles? By the way, 0 degrees. Yes, stay right here. Terminal side, same as initial side, staying right there. 90 degrees ends up on the positive y-axis. 180, 270, 360. And from here, any coterminal angles to this. Again, in other words, what? Minus 360. Or 90 minus 360, right? So negative 270. So either way, these are the angles that are not ending in any quadrants. They're called quadrantal. All right. Let's move on and see what else we could do.